Ladies and gentlemen, please welcome the Director of Education, Ted Bradshaw.
Hello, how are you all doing out there? Well, I guess you all is kind of a Texan thing, but you know, I really am a Texan, so you can't take Texas out of a Texan, right? Even if they're in Florida. But are you starting to feel like you've been walking a little bit? Maybe a couple miles, feet starting to hurt a little bit? Well, I understand that. We warned you to bring comfortable shoes, right? Well, that's good. I hope you got those, and if you're not wearing them, I hope you put them on for the rest of the conference. We got a lot of exciting things yet to go. We have really an information-packed hour here in the exhibit hall tonight. I know you're looking forward to it. You know, there's some things that you really shouldn't talk about, you know, unless you're among family. You should use a little discretion, right? And I'm thinking we're family, and I can just kind of talk about anything. Is that right? Oh, we can? Is that okay? I don't want to take any liberties here if I shouldn't, right? Well, did you notice this morning when Brian was doing his presentation that, you know, he didn't seem to care at all about the Paradise Island trip. It was the shirt he loved, right? Right? I mean, I thought it came through loud and clear to me that he loved that shirt. And I was a little worried when I left the stage and I saw that shirt sitting right there. And then when I came in here this evening and saw it was gone, I thought he would be really upset. I know how that feels because somebody asked me, Ted, they say, how come you're not wearing a tie? You always wear a tie. And I said, well, it is a traumatic thing. I do like my ties, but I was on an airplane over in Newark when I first went to work for Lucent. It was one of those hot days where they push the plane out, and you know, it is just terribly, terribly hot, and you start not to feeling good. And I didn't want to loosen up my tie, but I loosened up my tie, and then I started not feeling too good, and so I thought, well, I hope I don't have to go back in that little closet, you know, on these planes. You know how they are on 737s, you can barely turn around in them, but wouldn't you know it, I had to go back there, and took care of my business, and did the little thing, and watched this little blue swirling thing, and I saw something else. My very favorite tie was right down there with it. I said, oh, what am I going to do? You do this, you know, and you just kind of get rid of it, but I still miss that tie, you know. I miss my tie, so I was worried about Brian missing his, you know, favorite shirt. But when you know it, he got it after all. He has it on, so he shouldn't be too uptight for this presentation. And Brian, come on out, and we're anxious to hear what you have to say. Thank you.
Well, good afternoon, everybody. I think it's been a long day. This is my fourth presentation today, but I'm pleased to say that no human other than myself has had to listen to all four of them. So this afternoon's presentation, there's kind of a series of them between now and 6 o'clock, really talk about the future of engineering tools, and I want to cover that. And then we're going to talk about the future of engineers. So let's get started with the idea of the directions of innovations at PTC. We think about these 6 innovation dimensions or directions. We start with a core, and from that, then, we deliver and focus on new vertical markets, expanding our life cycle coverage, providing additional management capabilities, covering more design disciplines, doing more kinds of analysis and simulation, and improving the underlying technology and architecture of our product development system. I'd like to talk about each of these 6 dimensions and think first about what has been the core of PTC, and then what have we done recently or will do in the near future, and then what are some of the opportunities for the future. Let's start with vertical markets. I think everyone would recognize PTC's heritage is the heavy engineering focus inside of electronics and high tech and automotive, aerospace and defense, and industrial products. But recently, we've been expanding our focus to retail, footwear and apparel companies, to medical device companies, small and medium businesses, a shipbuilding focus, and consumer product companies. Now, clearly, with 50,000 customers, we have many, many companies in these industries today that we can call customers, and we're very pleased and thankful about that. But what this means to us is that we're increasing our focus. We're increasing our product focus, the capabilities of our products destined for these specific vertical markets. We're improving the way we engage with customers in these markets, this process focus that I talked about earlier today. Now, the product lifecycle management capabilities that PTC delivers is useful for other businesses as well. So we can imagine with the S1000D focus for technical publications that there are other adjacent opportunities in airlines, for example, or process industries like food and beverage or pharmaceuticals. Those product development problems are actually quite similar to those faced by discrete manufacturers, and many of the capabilities that PTC has today or could develop are really quite closely related. So I think that's some of the direction that you'll see from PTC, where we'll never lose our focus on the core. We're continuing to improve our products and offerings and the way we work with customers in the core, but this is about how do we keep growing as a company and what kind of technology can we bring to you. I think we'll also focus on lifecycle coverage. PTC's heritage has been in the design department, in engineering, with some capabilities upstream and downstream from that. But today, with the focus of NPM Link and Windchill, and with our acquisition of NCG, the new Pro Toolmaker product, you can see an increasing focus downstream in production. And I'll show you some things that I think validate our focus upstream in the process as well. And long term, our goal is to cover the complete product life cycle. When we think about management capabilities, these are the kinds of assets that we manage for customers, the kinds of things that customers trust us to be this single source of truth for. Our heritage shown in kind of the full fuel gauge of green there in the red square. We're really trusted for content management and change management and configuration management. But with some of the recent improvements in our product portfolio and some of the things that we're working on, we really feel like we'll expand that and add to that focus project management and resource management and program management. And in the long term, we really think that this defines the full set, or a rich set at least, of assets that we would like to be trusted with in your organization to help you manage that information. We also think about one of the dimensions of design disciplines. Clearly, our heritage is pro-engineer and the mechanical design process and the mechanical design discipline. And to that, over the years, we've added expertise in routed systems, in piping and cabling design. Through acquisitions recently, we've added the disciplines of math, or maybe more broadly, engineering. We've added technical documentation and technical illustration disciplines as well. But when you think about everything that's in the box of a product, we have today integrations with electrical tools, and I described some of those new capabilities earlier this morning. But I think with both electrical, electronic, and software, we need to have even tighter integration, a more rich cross-discipline design environment. So I think we'll continue to focus on that as we do our product planning. One of the core value propositions of product lifecycle management in any case is analysis and simulation. We have a strength in the mechanical disciplines of simulation, stress and thermal analysis, and mechanism, kinematics, and dynamics, as well as optimization and behavioral modeling. On top of that, recently and in the near future, we'll be delivering some additional simulation capabilities for tolerance analysis and ergonomics. And then in the long term, we really want to deliver a complete simulation. So this is how does software and electronics and the electrical system and the pneumatic and the hydraulic system interact with the mechanics and the purchase components. We really want complete product simulation. So that's kind of a long-term vision, but we can take step by step and make progress in that direction. And then the sixth of these 6 dimensions of progress is the technology that we use for Windchill, for our enterprise technology stack. Historically, we've been a Java application running on an Oracle database with a services-oriented architecture set of partners. Our first was Tibco, and then running on server operating systems from all of the major players. But we've been expanding that with the idea of making it easier for our customers to implement the product development system. So we've added, for example, Microsoft SQL Server as a database. We've added IBM as a services-oriented architecture integration partner. And in the near future, we'll introduce support for Linux as a server-side operating system. And that will continue over time, that as customers ask us and seek to better integrate Windchill into their architecture, I think we'll have a better opportunity to embrace all of the different technology options that are out there today. So this has been kind of the overview of different vectors, if you will, whether it's a vertical market or a process and lifecycle coverage or a simulation coverage. It's different ways to think about how we'll be expanding the product development system over time. What I'd like to do now is just share with you 4 relatively short examples of what I mean by this, by bringing it to life a little bit. The first is upfront in the design process, expanding Windchill to provide requirements management. We talked a little bit about this in previous conferences, and I think we're coming closer and closer to having a product that will be ready to release. The idea of managing requirements in Windchill is very powerful because of the linkage and the traceability between the product structure and the structure of requirements. We're not really talking just one structure of requirements. It's really first a structure of customer requirements, and then from that, a structure of system requirements or engineering requirements. Let's see what that might look like in Windchill. So here you see a list of customer requirements. You can drill into that requirement and actually see its heritage as well. Where did it come from? Did it come from the customer contract, or did it come from a customer interview? So if that's a complete set of customer requirements, now the system engineer's job is to define the system level requirements or the engineering requirements. A lot of times system engineers would like to work in Excel, for example, a spreadsheet application, to capture that structure very, very quickly. So here's an example of defining a complete set of attributes and requirements in Excel. But then Excel is not the master of this information. We'll import that into Windchill so that we get a real structure in Windchill, independently changeable, of all of those requirements. Now we have 2 structures, our customer requirement structure and our system requirement structure. We'll link those 2 together so that we have traceability between the 2. We'll say that these 2 system requirements are linked to this one customer requirement. That's really important later on, as you'll see, as we understand the impact of change. Now that we've created those structures of requirements and linked them together, let's see what it looks like if we generate, for example, or read a problem report. As we drill in, the problem report, attached to this problem report is a component, a physical part. Now when we look at that physical part, the requirements are also shown for that physical part. And we can track those upstream to show not just the engineering requirements, but the customer requirements. So now we have this linkage, this flow between the top-level customer requirement, the engineering requirement or system requirement, and then the actual part or assembly or physical instance that satisfied that requirement. We can look upstream or we can look downstream to understand the impact of a change. If we made a change in this requirement or in this part, what else would change? Things like other parts or other requirements or testing, for example. Now the important part, or the nice part, I guess, about having all of this in one system is that all of Windchill's power is available for managing these requirements. For example, a change report or a change notice or a change request. So here we're actually adding requirements to a change request along with parts or documents. So now we're not just changing parts or documents, but we're changing the requirements that drove those parts in the first place. I think this is really kind of bringing to life this power of an integral system that I talked about earlier today. Today, most companies are managing requirements in spreadsheets or in specifications, plain Word documents. By elevating those requirements, by splitting them out and separating them into discrete objects in Windchill, we have this ability to manage them and link them in a much more powerful way to help you improve your product development processes. The second example of the four that I want to talk about is a new collaboration method with Windchill. This one we call package collaboration. Package collaboration is about creating, think about it as a box, a container, that will hold all of the information that you want to send to someone who isn't a Windchill user, maybe a partner or a supplier or something like that. So it allows you to interact in Windchill and gather all of the information you want, package that together, and then put it in kind of a package, a box that you can export and deliver without having access to Windchill, still navigate the content and the structure and the relationships. Let's take a look at what that might look like. In this case, we're going to work on this bicycle crank. We'll actually copy this baseline, this ProEngineer data set out of Windchill, and we'll mark that as a copy and then create our work package. So now that we've copied that, let's go up to package and create a new one. Here's our list of packages so far, but we'll create a third one. It takes us through a wizard interface that allows us to set the context and the names and the attributes and so on. And the whole idea here is to define this box that we're going to add the content to. Now, as I generate that, I can also capture all of the related information, the associated documentation. So here's my new package. As I go into that, I'll paste that information that I copied out of my workspace or my PDM link folder. So there's my crankset assembly. And now I'll also gather, with all that information, the associated configuration or dependencies, related business objects, other change objects. The idea is to make a coherent and cohesive package of content that I can send to my supplier. Once I've defined this package, I can continue to add content, or I can say, let's lock that package so that I can't change it anymore. This will be the version that I distribute. Now I can keep track of what I've sent out to my supplier, for example. So by locking it, I make sure that if I have to revise it, I'll have to go through a process in Windchill. I can't just add new content. I'll have to create a new version of this package. Now I have this zip file in Windchill. I can send that to my supplier on a CD or FTP, whatever. And as you open up the contents of that zip file, you'll see all of the content and the metadata, all of the relationships. So this is the contents of the zip file. If I open up the index there, this is not connected to a Windchill server, but it's a Windchill package nonetheless that allows you to navigate through the content and the structure and the relationships. It really delivers a complete package of information to your supplier to allow you to have a good conversation and control that information flow back and forth. The third example that I want to give about where might we go in the future is around tolerance analysis. I talked a little bit about this at last year's conference, and we've been hard at work over the last year in trying to bring this to life. We've worked with one of our partners, Sigmetrics, to create a very simple and very well integrated capability in ProEngineer for tolerance analysis. Now, they already have a very powerful partner application for very sophisticated tolerance analysis capabilities. But really, the target market for this are the design engineers who are doing tolerance analysis today with paper and pencil and a calculator or maybe a spreadsheet. What we really want to do is automate that, include it in ProEngineer, make it a feature of ProEngineer so that those tolerance analyses can be repeated as the design evolves and changes. Let's take a look at what that might look like. we want to work on this little assembly and capture a measure between the sheet metal face and that plug component there. Once I've defined that measure, ProEngineer will guide me through the selection of dimensions and geometric dimensions and tolerances to create this loop diagram, the complete path that you have to follow in order to stack up the tolerances. So you can see dynamically the building of that loop diagram. And again, not just linear dimensions, but also the feature-based tolerance information. Then you get the normal measure, the nominal value, but you also get the distribution of tolerance, the sensitivity, and the contribution to the tolerance of each of the dimensions in the stack-up. So this is a feature in ProEngineer. This can be, you can have 10 of these analysis features, and each time you change or modify your model, you can re-verify that your product, your assembly is still in dimensional control. Now, if you have more sophisticated needs for analysis, this upgrades or kind of moves up the chain seamlessly to the full CE-TOL product. So this is still in research today, but you can see we're making some good progress, and I feel like we'll be in a position to offer this in the not too distant future. The fourth thing and final example that I want to share is one around ergonomics analysis. So almost every product that is designed in ProEngineer and designed in the product development system works with or is maintained by or is created by, assembled by a human. And so this interaction between the product and humans is really, really important. Think about service procedures, think about assembly procedures, think about the use of the product. What we really have been lacking is a very well-integrated, very simple and easy to use capability for ergonomics analysis. Not as a separate standalone application for specialists. Those exist today. What we need is a capability that any design engineer can use to bring the human into the design. In this case, we've been working with a specialist firm in Canada to help create this offering. Again, not available yet, not ready yet, but something that we're working on and you might see from PTC in the future. So let's see what that might look like. Here we have this product and we want to see how it fits with a human. So we'll introduce a human into the model. We'll pick a 50th percentile North American woman. Now she's in our ProEngineer assembly. And as we open the model tree, you can see she's fully anthropometrically correct with all of the right joints and flexibility. We can pick a posture that makes sense for this human on the bike and then modify that for the specific fit. This doesn't look like a very well-designed motorcycle at this point, but you get the point. That's the learning that you get from the application. We can also then check things like reach. With this position, where can the user, where can the woman reach? That's shown by the green envelope. Or we can check vision. What can she see? And we can see this both from outside of the scene as well as really what can she see, as if your eyes were her eyes. And that's an example here, looking down, and then you can change the head angle and see what she would see looking down the road. There's also further analysis capabilities you can have for things like posture comfort. Is the user comfortable in that position? You can add accessories. I'm not sure about the sunglasses, that might be for fun, but maybe your products are maintained by people that wear safety equipment, gloves or things like that. And you can also look at center of gravity to see about balance and safety. And this little section here shows the posture comfort that I mentioned earlier. That little colorful diagram there shows whether the joint is bent in a way that's comfortable for the user or not, comfortable for the human or not. So it looks like she's all set to go, raring the throttle, and everything's good to go. So that is our look ahead at a couple of the things that we have under development at the labs at PTC. You can see that we have improvements planned in Winchell, in ProEngineer. There's improvements in MathCAD and ArborText and IsoDraw, Product View. There's really these kinds of initiatives that are underway throughout PTC. We have about 1,500 people in the development organization at PTC. We have a very broad partner community that delivers us good ideas all the time and very, very pleasant to work with, many of them in the exhibit hall upstairs. So it's really a great opportunity for us to continue to expand the PDS to help solve more and more problems.